they also didn't have to really do anything. They just had to sit there and mope and not do anything. And that was just inappropriate. Inappropriate activity for someone who is facing a test that's going to determine whether they pass this class or not, and possibly pass high school or not, graduate high school or not. If you fail this class, you're not graduating until you pass it. Does that make sense? Yes or no? Okay, because you should take this test seriously. I don't know what else to say. I know you've been told by some teachers that it's not required for graduation. Indirectly true. It's not. Except if you fail this test, and you haven't done work, you're going to fail this class. That's it. And if you fail this class, that you're taking it again and again and again until you pass it. So it's up to you. And also it's going to damage your GPA. I don't know what else to say. Talking about professionalism and talking about your future. You guys are really intelligent people. How sad is it that you not putting some effort into reviewing is going to impact your grade? So let's see if I can get some participation on this class. I got it from my first period class. Second period kind of didn't at all. So they did an alternative. So let's see if it works here. So you had this for homework. You had it all last week. You had throughout last week to turn it in. Some of you did, some of you didn't. You still could turn in. My bet is there's going to be a few of you that will not turn in, will not do it. Okay. Just like dress code, your choice. But we're looking at the carbon cycle. That's what we're looking at. We have to consider what this means. It says what is taking out carbon. So let's look at what's taking out carbon from the atmosphere. Carbon dioxide in the atmosphere is taken out by plants. Carbon dioxide in the atmosphere is put back in by plants when they do cellular respiration, because they do cellular respiration. Carbon dioxide is put into the air by animals because they do cellular respiration. And carbon dioxide is put into the air by things by decomposers like fungi, bacteria, worms, etc., that take apart dead things and put that CO2. They do cellular respiration as well, and they put all that carbon dioxide back in. So let's talk about why as a review. How do these plants and animals do this? This is going to be warning 2.
What are you talking about?
So when we look at a leaf, in a plant. In this case, it's a leaf in a plant. But it could be a bacteria, something called a cyanobacteria. It could be algae or a plant. Any one of these can do this process called photosynthesis. You've gone over it. We've talked about it. Plants use these things called chloroplasts. And cyanobacteria don't have chloroplasts, but they do photosynthesis. In any case, these things, what they do is they take in CO2. Carbon dioxide goes in to the leaves. Into the leaf goes water. And into the leaf goes light. Light, water, and CO2 go in, and the leaf makes sugar. That is photosynthesis. And it also releases it releases as a byproduct. As a byproduct, it releases oxygen gas. Some of the gas it uses itself. Some of the gas it does use itself. Some of the gas it doesn't. So a lot of the gas is released. More gas is released than it uses. So since it produces so much oxygen gas, it releases a lot of it to the atmosphere. But it does use some of it as it does cellular respiration. So the plant itself uses some of the sugar along with some of the oxygen to do cellular respiration because it eats its own food. You should be writing this stuff down. Material, the plant, when plants make their own food, since these organisms make their own food, we call them autotrophs. Autotrophs make their own food. They eat the food they make, but they make their own food. A lot of the sugar they make, they put together to make their bodies. Okay. Now, in conjunction with animals, and bacteria and anything else that breaks this stuff down, we call these guys heterotrophs. Heterotrophs eat food. They don't make their own. If you're on a device, on a cellular device or a computer, I'm sending you to the office. I'm not going to argue with you. I'm just going to say, please just leave. I can't. I only got one today, and then tomorrow. I don't have time to argue with you. Heterotrophs are taking the sugar and they're combining it with oxygen and they're making ATP and they're making CO2. They're making ATP, CO2, and interestingly, they're making water in a process called cellular respiration. We've gone over this many times. We've done POGILs, we've done labs, we've done virtual labs, we've done actual labs, we've looked at the atoms and the molecules, and we've done tests on it. I've done everything I can do here for you to understand these processes, that these two, they go back and forth. It's interesting that the CO2 that we make and the water that we make in our bodies goes back to the plants. The plants take that water and that CO2, they make sugar that then comes back to us. And round and round this goes in a cycle forever. For millions and billions of years, this has been going on. Literally millions of years. The relationship between animals and plants have been balanced. We've had stuff going in. Here we have CO2 leaving the atmosphere. And here you have CO2 going back into the atmosphere. So back and forth in a cycle, the carbon dioxide is gone. Now we have some of the dead things, and again, over hundreds of millions of years, hundreds of millions, a number that is not even imaginable, longer than anything you've ever known existed before the continent of North America existed, back when it was Pangea. Like this stuff, everything has changed. All these creatures that were alive were buried, and they were turned into 3 or 4 different kinds of materials. Natural gas, which we use today to heat our homes, and here in the Cleveland area. Other places use other kinds of gas, but there it is. Oil, which we turn into gasoline. coal, which we burn in electric power plants to make electricity, and peat that we can burn for heat, or we could use it in fertilization processes. No matter what these are all made from dead things. That's why we call these what? What do we call these things? Well, they're natural resources. What kind of natural resources? What do we call these fuels?
Fossil fuels?
That's right. Fossil fuels. Natural gas, peat, oil, and coal are fossil fuels. Now, when we burn, these have been buried for hundreds of millions of years. Buried. They've taken out. That's why we call it a carbon sink. Carbon sink. Why do we call it a carbon sink? Because we've taken carbon out of the atmosphere and it's buried. It's out. It's not in the cycle anymore. Now we're taking that and burning it. We've been doing it for what? 100 years now. More than 100 years. We've been taking a lot of this. A lot of coal. Tons. Hundreds of tons. Thousands of tons. Millions of tons of fossil fuels. And we burn them. And we put them into the air. We put the carbon dioxide into the air. We're increasing, we're breaking the cycle. We're unbalancing. We have been living in a world, we've grown up and humans have been living in a world that's been balanced in nature. The amount going in pretty much equaled the amount going out. But now we're putting in more CO2 than plants are able to take out. And what's happening is the atmosphere is filling up. The concentration of CO2 is getting out of hand. It's out of hand already. Global warming is here. Because it turns out, well, before we go on to that, let's talk about, well, why is building a plant taking out CO2? What do we do with all that CO2? And why is eating putting CO2 in? You got to remember that we've talked about these molecules before. See if you remember them. Just say it when you recognize what it is. Is that what this is? A sugar? Now that's one biomolecule. Here's another biomolecule. No. Yeah, this is C1 to 2 to 1 to 2 to 1 ratio. You got that one, and you got the other one that looks like this. Those are the two we talked about. And then you have this one. That's right. This is an amino acid. It makes proteins. What is this one over here? C1 to 2 to 1 ratio of carbon, hydrogen, oxygen. What is it? It has a 6-sided version, a 5-sided version. It could be a chain or ribose is an example of it. Yes. Glucose. That's right. Sugars, carbohydrates. Carbohydrates. There's various forms. There's polysaccharides, monosaccharides, disaccharides, all that. So carbohydrates, sugars. What about this one with ribose or deoxyribose, nitrogenous base, and phosphate? What is that? We spent 3 months on this. There's no way. What is it? I can't hear you.
You said acid.
It is an acid. I'll give you that. Nucleic acid, someone said. Very right. Very right. Nucleic acid. And then you have these long carbon, let's see, these long carbon chains. Oh, that's not right here. So there's a bunch of carbons, and then
There's not a specific amount.
it can change depending on which carbon chain you're talking about. Some of them have single bonds, some of them have double bonds, some of them have double bonds. Oh. And some have, so some are saturated, some are unsaturated. Some are monounsaturated, some are polyunsaturated. What are these? You learned it in health. You learned it in biology. Yeah, yes, I did. I did. I talked to Skinner. Yes, he did. He taught you about saturated and unsaturated. Yes, he did. I guarantee it. If you don't, maybe you weren't there or didn't pay attention, but he did that. He did teach it. Say that again. Fats, yeah, fatty acids. Yeah, that's right. So fatty acids, or the big term is lipids. Also known as fatty acids. These are fatty acids, but the lipids include unsaturated fatty acid, saturated fatty acids. Both are necessary in your diet. So saturated, unsaturated fatty acids, there's cholesterol. So there's a lot of lipids. There are a lot of things that are lipids. There is a bad lipid you should always keep an eye out for in your diet to stay away from. There's this thing called trans fat. Stay away from trans fat everywhere you can. Look it up. This is a danger. We know that. We know for a guarantee. It's like smoking cigarettes, bad idea. Just don't do it. All right, so you got lipids, nucleic acids. So there's these four. These are the molecules that make up life. So when you eat, these are the four groups that you're eating. You're either eating lipids, nucleic acids, carbohydrates, or proteins. That's it. What do all of them have? What do all these biomolecules have? They do have oxygen. What are the atoms of what atom is common to all biomolecules? All life on this planet has what in it? Carbon. Carbon. All of them have carbon in them. These dots, these lines being connected mean carbon. All of them have carbon in them. That's why the carbon cycle is the way it is, because as we look at it, everything depends on the plants being able to capture that carbon. Without that, we can't make any more of us. We can't produce any more of ourselves or any life on this planet. It all depends on carbon. So when we mess with this balance, we're messing with life on Earth. When we add carbon dioxide, it changes a lot. Let's talk about what it changes and why. Here's some facts. Carbon dioxide. Increasing carbon in the atmosphere. Which for us mainly means CO2. For us, that mainly means CO2 in the form of carbon dioxide. But it also means methane, CH3. So this is methane. This is the stuff you burn in your stove, your water heater, your furnace. This is CO2. It's called carbon dioxide. This should all be a review. There's nothing here that's new. Increasing this carbon in the atmosphere, what it does is...
Part of the interruption was a driver of a black Mazda, license plate JBH 3385. Please move as you're blocking a semi-truck from getting to the jet. Again, with a driver of a black Mazda, license plate JBH 3385. Please move your vehicle. Thank you.
Christian, you gonna go move your car? No. It's gonna get towed. All right, so average carbon concentration leads to an increase in temperature, average temperature of the atmosphere. So what? So it gets warmer. Good. I don't like it cold anyways. Right? Right? I mean, don't you like it warm? But I mean, what's the problem with the average temperature increasing? Let me ask you, what does temperature mean? What does temperature mean? I've told you at least 10 times. Huh? See, some of you keep pulling out your phones. I'm trying to teach you the stuff you need for this test, and you're just on your phone doing whatever. I warned you. I'm going to send you. I think I recorded. Let me see. Have I been recording this? Yeah. So I recorded me telling you I'm going to ask you to leave. You can go. You don't have to be here. Go to the office. Just tell them, hey, I can't deal with class today. Put me in the planning center. Don't lay your head down and go to sleep. Because I'm going to ask you to leave. And don't be on your phones, because I'm going to ask you to leave. Temperature means what? What is temperature? No, I told you 10 times. 10 times at least this year. You've been tested on it. I literally put it on a test 3 times because I knew this day was coming. That's right. Average kinetic energy. Average kinetic energy. So what? Average kinetic energy of the atmosphere changes. Let's take a look at that. What we drew the other day. Let's take a look at this thing called the planet Earth. If we look at the planet Earth and we think about this thing that we call the atmosphere, because that's what we're talking about, right? Everybody agree we're talking about the atmosphere? Okay, because I sometimes I think people are only partially listening. In fact, I know people only partially listen to what I'm saying. You're talking about millions of tons of matter. You would be a speck right there. That's way too big. Look, the city of Cleveland would be something like here. There's a city. Let me do it in black so you can see. That's it. That's the city of Cleveland on the planet Earth. Look at the atmosphere. The atmosphere, I know you know because you've been alive for a while. The atmosphere moves, doesn't it? It swirls, it sinks, it rises. Air goes up, air comes down. I think you know that. All around the earth, these are things that are bigger than mountains. They're not as heavy as mountains, but it's a lot of matter. You've walked in a windstorm. You know you can get knocked down by the wind. Tornadoes swirl and rip houses from their foundations. They can throw a cow that weighs 1,000 pounds across, bless you, yes, across the city. This atmosphere is a big deal. This atmosphere brings with it hot or it brings with it cold. It brings with it dry air or it brings with it wet air. It can be wet or dry, hot or cold, and the more kinetic energy this has, what does that mean?
The more temperature there was.
Right, the more temperature, the more CO2, the more temperature, the more kinetic energy. What does that mean for the atmosphere? What's it doing? If temperature is the average kinetic energy, what is the average? What's happening in the atmosphere on average?
It's getting hotter. Or
It is getting hotter. So the kinetic energy is what? The energy of what?
it being used.
Movement. So as we increase temperature of the atmosphere, what are we increasing?
The movement.
The movement. The movement. So now you got what? More hurricanes, more tornadoes. Now you have more dry air where it used to be wet. We're in one of the great droughts in the West, is in a great drought. It's so bad that they've had to ration water. Like Los Angeles has had to, you can't water your lawn. You have to make sure you can only take a bath once a day. I mean, they need to ration water. In some parts of Texas, they started recycling urine. Like, it's gotten bad. Why? Because wet, and it's getting worse, by the way. I'm about to show you some pictures of some places that have dried up. I'll keep recording. I don't know if it'll record, though. I think it stops after I... So as you saw in those 8 examples, areas that used to be wet are now dry. Places that used to be dry are getting flooded. Do you know Louisiana, New Orleans? What do you think of when you think of Louisiana and New Orleans? Water, floods, right? Swamp, alligators, right? Do you know Louisiana? Parties, good, yeah. Do you know that Louisiana has been dry for a long time? They've had a drought. Louisiana, where everybody thinks of hot and humid, right? Not humid. Now it's just hot. It's drying up. It's not dry, but I'm just saying it's in a drought. So where people used to grow food, now we can't grow food anymore. So if you're thinking about, so what, big deal, some lakes dry up. Let's be clear, that means no water. No water means no plants. No plants mean no food. Those Cheetos that you love so much and Pringles, forget about it. You're not getting food in that way anymore. I see a can of Pringles right in front of me. What are you talking about? So, when we're talking about, so what, global climate change, the glaciers are melting. That means that the water sources for a lot of places are drying up. That means that the ocean is getting less salty. That means the currents that normally drive the ocean current, the things that drive ocean currents, that feed the fish, that feed us, are no longer going to move. So their fish are not going to be around for us to eat. We're destroying, this was a delicate balance that we had going. We had something good. We had a balance between plant and animal. The sun fed our planet, the plants made our food, we ate the plants. Now we're deforesting, we're taking out the land, we're building concrete buildings, and we don't have any plants growing in those areas. The plants that we do grow are monoclonal, which means they're only one kind of plant, corn usually, or soy. What time is it? And what time do we leave? So why are some people putting everything away? They don't even have, they just given up taking notes at all? Why have you put away all your things?
My notebook is right here.
Oh. Well, I'm missing. Could you take your book bag off there so I can see what you're doing? Thank you. So the question is, what are we going to do about it? What can we do about this problem? We can't change what we've already done. Our temperatures have increased. All these things that we just talked about. Look, there have been more tornadoes every year. There's more and more tornadoes. Why? Because we've increased the global temperature, which increases global kinetic energy in the atmosphere. Every year we get bigger and more hurricanes. The hurricanes get worse, and there's more of them. That causes damage. New York City flooded. It's a big deal. The ocean levels are rising. As water levels rise in the ocean, the land sinks. It's a double whammy. Because the heavier the water is, the more the land sinks. Which means the lower the land, the higher the water level relative to the city. Could you tap her on the shoulder? Could you tap him on the shoulder? Tap him on the shoulder. Yeah, don't hit him. So, bottom line, when we're talking about global climate change and carbon dioxide, the question is, what can we do about it? Some people argue we can take some of the carbon out of the air. Obviously, some things that would make a difference is plant more trees. That would help take out some of these, use less fossil fuels, if not get rid of them totally. We're hoping that something like fusion energy would come into play. These are solutions to the problem. I hope you're writing these things down. Obviously, when I say that, what I really mean is you're not writing them down. I wish you would so you can prepare for the test. And you're not doing it. So here we have plant more trees, use less fossil fuels. Some people say use CO2 scrubbers. You could take CO2 and take it out of the air with big machines, big factory stacks that suck in CO2 and trap it in a solid form that you can then bury it. Basically do the reverse that we've done with fossil fuels. It just seems like that would be a lot, but that's a possibility. We could start taxing people. We can incentivize sustainable practices. You know, some of the things that... You have your hand up? Yeah, go ahead. I can't hear you. A big what?
Like a machine that takes... No, not ice cream. Like actual, polluted air. And makes it colder, and the warmer air is.
So you want to make it? You want to take and make it colder and warmer? Yeah, that's a misunderstanding of how physics works, how the world works. So let's think about that. You're thinking of like a giant refrigerator, right?
That or
air conditioner. Okay, so let's look at a giant refrigerator. Here's how your refrigerator works. Here's how your air conditioner works. I don't care what it is. You don't make anything colder without making something else hotter. All you're doing with a refrigerator is you're taking and the heat is going out into the room, and inside the refrigerator it gets colder. That's how refrigerators work. You're exchanging heat. You cannot get rid of heat. All you can do is exchange it. Air conditioners, what they'll do, and you know this because if you ever put your hand on the outside of an air conditioner, you can feel the heat. When it's cold in your car because you got your car AC blasting on max, have you ever felt your engine? Yeah, it's hot. Your engine's very hot. The only thing you can do is exchange heat. You can get rid of heat by pumping it out. That's fine. But you can't get rid of it. So if you have a city, let's say you have the city of Cleveland, and it's too hot in Cleveland, so you're like, make this plate, put a globe over it and pump out the heat and have cold inside. That's great, but that's that only works if you have an enclosed area and you don't care about outside. This is not inside outside. This is the earth.
Is there a way to minimize trends? What is it? Is there a way to minimize?
The way we can minimize the increase in temperature is by reducing the amount of CO2 we put into the air. We can only increase the amount of plant life on the planet to a certain extent. We can increase the amount of permanent plant life by planting more forests, planting less corn. Because growing agriculture does grow plants, but we use it very quickly. They eat it, and then cows belch methane, and when we eat the steaks, or they rot because we don't eat it. We throw away the hamburgers, because I've seen people eat half a hamburger, throw it away. When that rots, either because bacteria or fungi eat it or we eat it, we make CO2. So we're putting all that carbon dioxide back in the air. When we put methane, when we fart or when cows belch, they're putting methane in the air, which is even a worse carbon dioxide gas. So it doesn't sound like a big deal when you fart, but when 9 billion people fart, that's a lot of methane. When billions of cows burp, they burp up methane, that's a lot of methane. Yeah.
So us farting is ruining the earth. That's part
No, what I'm saying is that when we have so many, when we do anything too much, when we have too many babies, too many people on the earth, eating too much meat, yes, that's the problem. We're putting the whole world out of balance. So you ask me, what are the solutions to the problem? Plant more trees, plant more plants, more forests, ecosystems that will take carbon out of the air. Please stop speaking. Use less fossil fuels, whatever that means. That could mean switching over to electric cars. That could mean using natural gas instead of coal, because coal produces more carbon dioxide, more pollutants. That could mean incentivize sustainable practices. So you can give tax credits to companies that reduce their carbon footprint. Use public transportation instead of everybody driving their own car. There's a million. Buy an electric car. We have that option now. We didn't have it when I was a kid. You can have companies trade. If I have to burn coal because that's the way, if you have a steel company, you have to burn coal. Have them trade tax credits. We call them, you can call them coupons or something, and you can have them trade the ability to burn coal. Why is this not working? You can trade the ability to burn coal. Maybe let me burn this many tons of coal so I can make my steel, and I'll pay you money so that you can use less coal. And in your company, maybe we build an electric solar roof or whatever, and we can trade that so that the whole world is using less coal. So those are called, carbon tax or carbon credits. And we could trade those carbon credits like we trade money. And we can reduce the amount of carbon we produce as a world. Yes?
Isn't lithium mining really bad for the atmosphere too?
Wow. It's so intelligent. Where'd you hear that? Because it's absolutely true. Yeah, lithium mining, and it's not just lithium, it's precious metal, rare earth metals, right? So precious metals, that are rare earth metals, any mining It's bad, not so much for the atmosphere. What's bad for the atmosphere? Any kind of burning of fossil fuels is bad for the carbon dioxide in the air. But these rare earth metals, when we dig, what happens with mining, often people dig into the ground. What used to be, let's say it just used to be this beautiful forest, or it used to be a forest, right? With trees and birds and animals and whatever. And you want to get the lithium that's down here, this layer of lithium that's here, and maybe there's some cobalt here, or maybe there's some, I don't know, some zinc there. You can make money, right? You want to make money, so you want to dig it up. What are you going to do? You're going to tear out the forest. Oops, less carbon dioxide leaving the atmosphere, right? What are you going to use to do all that? Big machines. And what do they burn? They make carbon dioxide by burning gasoline. So you're putting more and more carbon dioxide in. Then you tear out, you make a big old hole. And you're digging it all up. And you get your precious metals. That's great. But in order to get it and to refine it, you have to use chemicals. So now you got this layer of toxic chemicals.
Why you gotta use chemicals?
You have to use chemicals because you have to separate the metals that you want, like lithium, etc., from the rock. So you got to use chemistry to do that. And often what's left over is this thing. There's a word that they call it. You probably have heard of it in sci-fi movies. It's called toxic. Some people call it toxic sludge. And you leave that over, the river, this fills up with water, and what do you get? You get a contaminated water, contaminates into the groundwater, the water around it. That land is not usable. You have a lake full of acid. Somebody jumps in it, gets burned. I mean, I could show you, watch.